Hello and welcome to our calculus video. In this video, we will be showing you how to find the calculus behind longboarding and pole vaulting.
As Taylor was going down the hill, we had a few questions. One of these questions was how high was the hill? Another was how fast was he going when he crashed at the end of the hill? The second time he went down a hill, we wanted to determine how much faster he went when he pushed off instead of from starting from a standing position.
Ready. Alright, this is our real world problem. Our distance was 18 meters. Our first time was 14.69 seconds. Our second time was 8.32 seconds. We are looking for both velocities, both accelerations, and the height. For our first velocity, it is v1 equals d over time, which is distance over time. Velocity 1 is equal to 18 meters over 14.69 seconds, giving us a velocity of 1.225 meters per second, or 1.23 meters per second. Our second velocity is also equal to distance over time, giving us 18 meters over 8.32 seconds, giving us a velocity of 2.16 meters per second. Now we're going to find the accelerations, which is equal to velocity over time. Our first acceleration is equal to 1.225 meters per second over 14.69 seconds, giving us an acceleration of 0.0834 meters per second squared. Our second acceleration is also equal to velocity over time, giving us a 2.16 meters per second over 8.32 seconds, giving us an acceleration of 0.2596 meters per second squared. Now, in order to find height, since we've already found velocity and acceleration, we are going to use the difference in kinetic energy and difference in potential energy. Difference in kinetic energy is equal to 1/2 mass velocity squared. Difference in potential energy is equal to mass times gravity times height. Now, since they're both equal, the differences are equal to each other in energy, we can set the equations equal to each other, giving us 1/2 mass times velocity squared is equal to mass times gravity times height. The two masses can cancel out, since, Then we have 1/2 velocity squared is equal to gravity times height, giving us a height of velocity squared over 2g, gravity. Our height is equal to 1.225 squared meters per second, divided by 2 times 9.8 for gravity, giving us a height of 0.0765625 meters.
A longboard is traveling at a velocity given by f of v equals x squared minus x plus 1. Find the distance equation, then, using the distance equation, knowing that f of 3 equals 1, find f of 5. So first the step is to find the integral of f of v. Since f of v equals x squared minus x plus 1, the integral of f of v equals f of d. F of d, which is the integral of f of v, equals x3 over 3 minus x squared over 2 plus x plus c. We can find c knowing that 3, 1 is the point. So if we plug in 3, 1 into f of d, we get 1 equals 3 to the third power over 3 minus 3 squared over 2 plus 3 plus c. That equals 27 over 3 minus 9 over 2 plus 3 plus c equals 1, which actually equals 9 minus 9 over 2 plus 3 plus c equals 1, which finally equals 7.5 plus c equals 1, making c equal negative 6.5. Now, knowing that c equals negative 6.5, we can plug it back into the original equation of f of d. So f of d now equals 1/3 x cubed minus 1/2 x squared plus x minus 6.5. F of 5 equals 1/3 5 cubed minus 1/2 5 squared plus 5 minus 6.5. Then this equals 41.662 minus 12.5 plus 5 minus 6.5, giving us a final total of F equals 5 equals 27.662 meters.
Math, yo. So now, we know that Joe is thrown up at a velocity of 3 meters a second, and he is exactly 1 meter off the ground at this point. We want to find how long it will take him until he is at his peak height, and what that peak height will be.
So first, we will show you that S double prime of t is equal to V prime of t equals AT when we are talking about distance, velocity, and acceleration questions. Now, Vt equals negative 9.8 t plus 3 equals 0. Now, we solve this equation for t in order to find the time of the velocity when the velocity equals 0, aka when Joe is at his max height. So negative 9.8 equals negative 3 divided by negative 9.8, and then t equals 0.3065, which is the time of the maximum height reached.
So now, we know the time it took for Joe to get to his max height, and his max height, which is 10 meters. Now, we want to use the equation to determine how long it will take Joe to hit the ground, because if it takes longer than 1 second, he will freak out.
Okay,
Now that S of t equals negative 4.9 t squared plus 3t plus 4, solving for this equation, we get that time before Joe hits the ground again is 1.26 seconds, aka Joe freaks out.
Thank you for watching our video. Have a great day.